So let's get started. Okay, my name is Brady Johnson. I'm the project lead for the OpenDaylight SSC project, also for the OP&V SSC project. This is my colleague here, Vinayak, Joshi. Want to present yourself?
I work for Ericsson, and I was involved in the SFC project during helium days. Then I was off. Now I'm back. So I'm looking into service chaining aspects in Ericsson SDN service chaining solution.
Vinayak is one of the original committers in SFC. He's been around since the beginning of time, so it's good to have you here. So let's see if we can get this to work here. So today we're going to talk about the new features we have planned for the boron release. And as you can see here, there's quite a few features here. I don't think we're actually going to have time to cover all these features. So what I wanted to focus on is the first bullet point there and the sub-bullet points there. So before getting into that, I'll go briefly through some of the other things that we have planned from different folks in the project. Our colleagues from Intel are talking about doing an NSH proxy. NSH is a service chaining encapsulation, something new that's been presented or being implemented in OVS. The problem with NSH is not all service functions support it, so you'll sometimes need an NSH proxy. So they're going to implement that. There is an NSH proxy available today, but it's kind of a small Python-based thing that doesn't work very well, and I think they're going to do a bit more robust solution. The next thing, enhanced application coexistence. This is basically, we already have application coexistence available today, together with our colleagues Sam and Andre from Red Hat, and also Keith Burns from the GBP project. But basically what that is if you think about it in an OpenStack environment, on BRint, we need multiple applications on the same switch, on the same OVS. And we need to somehow share the tables so we don't overwrite each other's flows. So we've come up with a way to do that in Beryllium, but I'd like to enhance that in Boron. And we've already been talking with the guys from NetVert and GBP about how to do that. And as I mentioned here, actually the name has changed. It's not generic network functions anymore. There's a new project that some of our colleagues from the VPN service, they're going to take some of the VPN code out and make a new project. We're going to end up calling it, I think, the generic network services. That way, generic network services will be GNS, so we can call it Genius. So that'll be a new project that we'll talk about and how we're going to use that and integrate with SFC. Also, next point here, we would like to integrate with the ODL VPN service in this release. FIDO integration, I guess Ed is not here. Surprised Ed's not here. Yeah, he spoke about this the other day, but FIDO is a new type of switch that we'll integrate in this release. Statistics, traceroute, diagnostics. We need to be able to troubleshoot service chaining, where are the packets going, what's happening with the chains and all that. And as I put here, the list goes on. There's a lot of things that lots of different folks want to get into this release. So, but as I mentioned, I would like to focus on this first set here, the automating service function creation, and that is via using this Genius project, the generic network services. There's a particular part of that project we want to take advantage of called the interface manager, and using that interface manager will allow us to do service function load balancing, failover, dynamic insertion and removal of service functions, which our colleagues from Intel want to implement as well. It will also allow us to do some of this, make the service function configuration a little bit easier. So let's jump right into that. If there are any questions on the features, or interrupt me at any time if I'm going too fast. Yes? To what extent are we closing the data plane?
Finishing the work on the data plane. How do you see the balance between the two events
Yeah.
For me, it starts getting more into what is the northbound APIs, how I see this evolving, how do I define service functions, how generic that could be in the context of orchestration solutions.
Yeah.
Let's see, from
Yes.
the controller like
I think.
OpenDaylight, and I think there is value in going in that direction. Obviously, it would require coordination between different communities,
Mm-hmm.
but that's anyhow, when you have some time, that's what you're doing anyhow.
Yeah.
Go on.
I think if I get into the next slide, that'll probably answer a good bit of your questions, or did you want to?
Yeah, it's mostly about the northbound modeling and how you set up the forwarding, whatever we are suggesting, the independent of the data plane. I mean, we don't preclude NSH, we don't preclude no NSH forwarding. It's independent of that. Yeah, it's mostly the northbound that we are talking about.
Yeah.
I don't know if I missed it, but how is the how are the service functions going to be created automatically?
Okay.
Okay, thank you.
Right. Okay. Let me get into it. Yeah, that's a bit misleading saying automatic service function creation. It actually, Vinayak will go over that in the next slide, but it's more kind of, I would say, the automatic service function forwarder creation. We're going to clean up a bit the way that works. So let me go over the way it works now, today. And keep in mind, this is, although I don't mention in the slide, this is in the context of OpenFV. All right, and that's one of my major goals in the OpenDaylight SFC project is to make OpenFV SFC work better and work well. So this is how it works today, basically, in the context of OpenFV. Here it says orchestrator, this Tacker, right? Tacker's, for those of you not familiar with what Tacker is, it's a VNF manager. It's an OpenStack project that basically manages the life cycle of the VMs for the SFC service functions. So it's an entity there that when it receives service function configuration, it spins up the VMs and manages all the VMs. That way, OpenDaylight doesn't have to, OpenDaylight shouldn't do that. So it takes care of that piece. So anyways, so as it is today, the service function is configured in the orchestrator, right? The orchestrator receives, okay, I need to create a service function. Has a bit of logic here that it knows if there's a VM that has been spun up for that yet or not. Let's take the case where it hasn't yet, so then it will spin up a VM, do its thing here, go through Neutron, get all the ports. Then orchestrator will talk to OpenDaylight and say, here's a service function, here's the configuration for the service function. And the next step, and actually what we want to focus on in the next slide about the service function forwarder automation is this number 5 and number 6. As it is today, you need to know, okay, the service function forwarder is basically the obvious bridge. You need to know about where is that service function forwarder for that service function. You need to know that in the northbound. And you need to tell the orchestrator here, okay, first create a service function, and then here's the service function forwarder that service function goes with. Doesn't really make sense to do that at this step because the orchestrator created the VM, so he should know where the service function forwarder is, right? So these last two steps here are what we're going to address in the next slide, which, as I mentioned, step 5 is the orchestrator receives the configuration for the SFF and then effectively forwards that on to OpenDaylight here. And this here, areas that we want to improve or address is the service function forwarder details are needed northbound, which doesn't really make sense. And then the service function forwarder to service function relationships are static, and they're not easy to change. You need to know it northbound. So that's what we want to address using this interface manager, which will allow us to automate that configuration. And then Vinayak will get into that. But once we do that, and once we get that automated service function forwarder configuration, then also we can take advantage of this genius project that has the interface manager and all that to get the rest of those things that we mentioned there, the load balancing, the failover, and et cetera. Okay? I don't see you too convinced, Andre. Oh, okay. All right.
There's another, this is the SFC pieces of it. There's other pieces going on.
Yeah.
So like network, for example.
Yeah.
VM gets created and sets up a net, connects it
Yeah. I'm just showing here what we need to show the context of the service function for. There are more things. You need to create the service chain. You need to do the netvert stuff, the classifier. Yeah, there are a lot more things. Do you have a question? Or okay.
So what does tracker communicate with the VM once it creates the
I'm sorry?
you said tracker communicates the configuration of the VM to the ODL. So what does it communicate?
Yeah. In case of OpenStack, it would be the virtual port, the neutron port.
But not today, not yet.
Yeah.
What we want to go towards, it will have that.
Exactly.
Yeah.
So-
Yeah, but yeah, basically the details that that OpenDaylight needs to know about the service function, its IP address and things like that. The type of service function is it a QoS, is it a DPI, those sorts of details. But then yeah, in the next, yeah. So let's go ahead and I'll pass this over to Vinayak.
So, first few things are similar. So essentially, important things are these two things, the number 1 and 4. They're swapped here. What that means is, not really swapped. Essentially what it means is when you are configuring a SFP, I would say, where you have to configure the SFP hops, where you specify SF, SFF, SF, SFF, this sequence of such pairs. So you ought to know where SF belongs to, okay? So, but then in a cloud environment, you may not always know where a VM comes up. The idea is like the one who configures SFC should be able to say that, okay, I want to have these kind of services, okay, I mean in a certain sequence, and let the controller, rather SDN controller here, figure out where those SFFs are after the cloud instantiates them, okay, and stitch the forwarding plane. So that is one of the things that we want to achieve. Maybe I'll open my slide deck later if need be, where you can get into more network details. So here it's more of a orchestration part. So a bunch of things are same. What happens is, as we discussed, neutron port UID.
The pointer.
I guess, yeah.
The pointer, yeah.
So this is what you are discussing about. So essentially the attacker or, not necessarily attacker, anything, any orchestra, OpenStack based, that's where you talk about neutron. So this neutron port UID is the one which tells me not exactly where, what is the identity of an entity that connects to such as OES switch to a virtual machine, okay? So that is what is given to the SFC, that its configuration flows down to the SDNC as SFC configuration. So all you are going to say is, okay, I am going to have perhaps some SFF and SF1, another SFF maybe and SF2. However, these SFs, they connect to the network using these neutron ports, okay? So now, later, let us say that VM comes up, the SFVM comes up. So typically, in any ODL, any open flow plus OpenStack integration, this neutron port translates into a tap port, okay? Say neutron has some 16 character UIDs, the tap port will have 11 typically, tap 11 characters /0. So it is the same name, translation to tap port. So what this means is, this tap port acts as an open flow port, okay? So what that means is, here is an OES, the orchestrator brings up a VM, connects the tap port from that VM to the OES switch. Then OES switch sends an open flow up to SDN controller, okay? Thereby informing the controller as to where the VM come up, okay? What this means is, now the controller knows the SF's location, what switch it is connected to. This is how it can stitch the forwarding plane. It is not known beforehand. Okay, so this discovery is kind of the strong points of this proposal as to where it exists, and it can move around as well. Okay. Thanks.
I'll keep it if you're going to keep going through the slides, sir. Yeah, yeah. So go back one maybe. Yeah.
Oh.
So this is the trick here, right? This is the new piece that we're going to use. Here I have the generic network functions. It's actually generic network services, right?
Yes.
And here, as Vinayak said, the SFC is going to receive information about that VM that we can take and pass here and say, I have this port UID. Tell me the SFF. Where is it? Right?
I was struggling with part of the discussion, and I wasn't there for the whole discussion yesterday about the Genius stuff, but part of it is that in the center, if I want to prune the tunnels and I don't want to have a N square, then actually I already have in the controller the knowledge of where a given VM is. I don't need to notify it again for the specific role it plays in SFC. SFC needs that, but not the network virtualization, right?
Two things.
So actually what you could easily do is you get an SFC request, you simply go talk to the table that you already have in the network virtualization. You don't need any activity from OPS.
The network virtualization, someone has to populate that. In our case, the Genius interface manager provides that virtualization support in the sense. Here is a neutron port, which is a interface, by definition. And where does that interface exist? In the sense, you want to populate this, right? Unless you get an OpenFlow event up, right? You wouldn't know where that VM is. OpenStack, Nova, and Neutron together, they won't tell you. They won't tell the controller as to where exactly they have brought up the VM. All they say is here is a Neutron network, and there are a bunch of ports in it. Okay, and
I don't think we are arguing over that. All I'm saying is that that activity of associating a VM with a physical machine is part of network virtualization. It is not part of SFC.
That's right. Hence this thing. Yeah, this is where that distinction.
You need it in a broader context than just SFC.
That's correct. So precisely that's why it's bifurcated. If you see the SFC doesn't really keep track of where the VM is. Okay, it talks to this Genius interface manager. That is the one which is tracking where it is. And as per discussion yesterday, this doesn't feed into only SFC. It feeds into L3 VPN, L2, anything. Because unless you know where the VM is, you cannot set up your OpenFlow pipeline. Yes, that's right.
Yeah, it's like I said previously, the trick here is that since the orchestrator is bringing up the VM, it can give us the information we need to know about it so that we can ask where it is. That way, notice here up here that now you don't need to configure the service function forwarder in the orchestrator because we can figure it out.
So all of this to me is data plane. But I have this following request. I want to have a classifier definition, service function A, service function B, etc.
Mm-hmm.
So how is that, or is that out of scope?
Yeah, we're not really, those are extra steps you need to do, but these two diagrams, this slide and the previous, I wanted to focus on the service function and service function forwarder part of it, because that's what we're addressing first. But I would think the classifier, the SFP, the SFC, all that would be the same. I don't think that's going to change, right?
No, but how do you perceive is the northbound API to feed that classifier definition, and where is that classifier in this diagram?
It's not. Well, I don't know. Maybe you guys can, Sam or Andre, talk about how NetVert is configured. I really don't know how that's. Never seen how it's configured, but
Classifiers are, it's another REST call. They just don't have to.
Yeah.
It's the same one from the orchestrator.
Yeah.
To network.
Yeah, so I think it would be useful to get it to the next level of let's agree what is a package that is an SFC request. To me, it is the classifying rules and then what service functions participate. The minute we say what are the service functions, we could also, and I don't know if we could achieve it now, but next gen we could say, okay, I really have a catalog of all of those firewalls, and I'm going to pick this one based on whatever criteria. This obviously is north of OpenDaylight right now, but at the end of the day, what we need to get is whatever resulting request comes down, because a richer situation would be I have that is load balancing, this is a check, I have multiple firewalls, okay? So that specific request is really targeting this particular instance of it. So we could start building that kind of an infrastructure and make sure that we could support it in open data.
But we have that with the selection algorithms that Danny Zhu and Yi Yang. Is that you're getting?
I don't believe
not as much as they should. There's some issues there that we need to address.
It's not that
Yeah.
we're trying to promote that, it's actually just trying to make the whole SFC stuff, I would say, a little bit easier to consume from the node.
Yeah.
So,
Yeah. Okay.
Yeah, and to your point there, so it's, the SFC, everything from the SFF to the SFs, on that chain, whatever that SFC chain is, they handle. But the classifier sits outside of that. Netbird handles it, or GBP handles it today. But I agree, it's kind of, because, Netbird has a different way to classify. They use the same ACL that SFC defines. GBP uses a different one, it's in their policy classifier.
Yeah, it's completely different, actually. Yeah.
So I agree, it's kind of difficult to look into.
Yeah.
It's very hard for a user to say, okay, here's the exact API that I'm going to use.
There's a question in the back.
Trying to catch up. Line 4, SF configured in ODL.
Yeah.
What all is configured?
Yeah, so, yeah, that's a little bit unclear in the sense, when you say SF is configured in ODL, here you can see it as SFP, service function path is configured. So that uses this thing, neutron port UUID. Okay, I mean, you need to provide a locator for the SF, right? So locator is the, exactly, so yes, that's right.
Yeah, but it's the same as today, right? Just adding on the port ID.
Yes, yeah, there are already locators. We are adding one more entity to it. So the difference here is this neutron port UUID doesn't tell you at this point in time, need not tell you rather, that which SFF or which OVS it is connected. It is just a virtual entity, so that when really the VM comes up, right, you know that, okay, it has come up with this particular port in some, OVS 10 or whatever. So that is the difference, actually. So this is virtual in that sense.
I shouldn't say adding. I guess we're augmenting, right? We're
Augmenting, right, that's right.
That's the
Yeah.
verb. Yeah.
So what's different today, though? So today, I mean, and that's the stuff that we kind of put in the workaround that we just added recently. We use the port name as opposed
Yeah.
to the neutron port ID.
Yeah.
So what, is there something more dynamic? I mean, it seems like we're still doing the same thing.
Yeah, but notice.
Use a generic network.
Yeah, but notice on the northbound on the orchestrator. Okay, we don't go into the rest of the configuration, but we no longer need to configure the SFF. That's the main difference. We don't need to configure the SFF on the orchestrator. We're figuring that out internally. Yeah. Yeah.
Yeah.
Okay. Notice step 5 there. We have to configure the service function forwarder in the orchestrator. Why do I need to know that northbound? When the orchestrator brings up the VM and can give me the information that I need to know to figure out where the service function forwarder is, right?
So even the code today, you can just simply ignore the fact that you're looking for the SFF. You can dip into OVSDB and say, hey, tell me where this port is.
Yeah.
And he'll go return you back the SFF too. Okay.
Yeah, I mean, just to add to it, even the VM mobility, right, live mobility we can bring in. I mean, it's not like that is the only thing we are targeting. But if a VM moves, right, internally, the controller can keep track of, okay, where the VM is and accordingly change the forwarding tables, as opposed to SFP again being reconfigured, if it moves. So that's another.
So you're looking at the events being generated when the forwarder moves to a different VM?
Yeah, when the VM moves.
When a forwarder moves, no. When a function, a service function
Service
moves.
function moves. That generates certain OpenFlow events. I mean, if you're talking about OpenFlow, and that connects to the connection is here.
How do you determine the migration of VM mobility controller?
I mean, currently, I mean, if you just use OpenFlow, right? I mean, it's simply you'll get OpenFlow down and OpenFlow up in another switch.
That is very generally given, right?
Let's see.
When you say that the port came up, it's like there are a lot of ports connected, somebody added a port and up it.
Yeah.
I mean the VM migrated, right? Even the port comes up.
No, that's the difference in the tap port thing that you talk about. So the neutron port, that characters of 11 characters are neutron port ID are the same as the last 11 characters in the tap port. I mean, that's how you associate. So you know that, okay, this is not just any other OpenFlow port. This happens to be a tap port which maps to this neutron port. By the way, this neutron port is where my SF is connected. I mean, all that information is here. the SF knowledge is here. Just the fact that, okay, that port is connected to this SFF. So that is how the connect is made. Yeah.
How is the initial, can you explain how did the initial UUID was known to ODL in the first place?
Okay, that is where known to ODL in the sense when you are configuring the SFP, or let me generally call it SFC, right? When you are setting up the data plane locators of SF, right? You have to feed in from the OpenStack into that. I mean, there is.
That's still manual.
Yeah, that's as of now manual, and there is some OpenStack definition of service chaining coming up. It's called port chaining. It's not really up and out there yet, so it's still coming in. So then probably that can be, you can translate that into this as well.
Yeah, but
So
if I understand the question correctly, where do we get the information? In the step 2, is where we ask OpenStack to spin up the VM. There we can get the tap or the port and feed it into step 4. So that's how OpenDaylight gets that information. Is that what you're asking? Yeah.
I'm trying, that's what I'm trying to understand, the difference. You could have done that. You're not changing anything in the orchestrator, are you? Or,
No.
Yeah. Yeah, a little bit, yes.
So previously you were actually explicitly creating an SFF?
Yeah, yeah.
But you didn't need to, right?
How does SFC know about the SFF if we don't do that today? So
You just know, you're told about the service function, right?
yeah, but
You just automatically created the SFF.
we could, but if there's more than one compute node, we don't know where it is.
You do based on the port ID.
Well, now we can, yeah. Well, with this change, yes, but the way it is today, no. It's
We're getting the port ID?
we're in a different context. I think you're talking about from this change from Tacker but that's for this workaround, this NSH workaround. I think you're talking about something different, right, Sam? Yeah, yeah.
Essentially, as of now, you have to spell out. Okay, here is the SFF that is connected to SFF1. SFF1 happens to be OVS1, let us say. Okay.
As Tim Rose said, today you have to spoon feed SFC, to spoon feed all the configuration and give it everything just right. So I'm trying to clean it up a bit.
So when the VM moves, can the UUID change? It can go to a
No,
different port, right?
no. As per OpenStack, whether it's live migration or not, the Nova is the one which is doing it. It doesn't change the UUID. If it changes, it's a totally different UUID. Then it's treated as a different service function altogether. UUID does not change when you move.
So, Vinayak, you said there is a relationship between the tap and the cluster flow. So, is it by convention or is it a standard?
It's a standard. I mean, that's how typically, it's not built SFC as such. In general, when the OpenStack, OpenFlow integration, so-called, that's how the ports are created. There are 16 characters there in UUID. OpenFlow port name is again 16 characters. But you cannot just copy all 16 because Linux expects some, decent names. So tap, turn port, or whatever. So tap is what gets created. So you pick up 11 characters, okay? Hope that, they being random, they are random enough. And 11 and 11, there's no coincidence where, first 11 characters match with some other port, etc. So that's how typically, OpenStack, OpenFlow integration is done. Right.
Lots of questions.
But
Yeah.
there is a room for a little bit of error, like you said, right?
Possible, yeah. Yeah, that's correct. 5 characters, so 11 characters being the same, UUID, so, probabilities.
It is possible, it really depends on the random number.
That's right. But yeah, that's how most of the L2s and L3s are currently working. If you go to regular OpenStack L2 networks, and OpenStack Neutron defines a network, but then on the forwarding pin it has to be an L2 entity, L2 forwarding entity distributed switch. So this is how you derive.
So why don't you use the OVS southbound plugin to do that? Because that anyway will give you a UUID of the port also, right?
Okay, so
Wondering whether you are using OpenFlow plugin to kind of up and down port.
that's right.
Same thing you can get with OVS DP also.
I guess, yeah. Maybe that's a second, yeah. Maybe, yeah, that's a good
That
idea.
you can use with the UUID itself, you can figure out where the port is there, because that UUID, whenever Nova create, I think that dumps that UUID into the extra configure, external IDs, right? They put in some there in another config, from where you can get that port UUID and say, okay, this is the port
Yeah. So this project, the Genius project, is a new project. So I mean that's the idea we had today. But I mean, if you have a better idea, please
Yeah.
come and
Uh,
let us know.
One of the advantages of port up, port downs is it's kind of seamless even for say mobility or regular port up down. Everything will be handled same. But as you said, when the port up event comes, then maybe you can talk to OSDB. Okay, is it really the UUID I'm looking for? I mean, is there due to coincidence there is a match to serve them?
Get for cloud one plugin also.
Okay.
Okay.
Because it's very proactive.
Right.
Update in operational state, it goes.
Right. I mean, you can monitor the DB. Yes. I mean, yeah. OpenFlow is one example that you am talking about. Yeah. It's not tied to. This thing is not really tied to OpenFlow alone as such. Yeah. There is scope for improvement. You can use OVSDB. Instead, it's much clearer.
Uwe's been trying, and then Jeff is next. Go ahead.
So I want to go to the SFF. So I guess there is an assumption that all the nodes that participate in the network virtualization also have an SFF that is being brought up originally. And then when we get a specific request, the configuration of the SFF really means that we're giving a unique SPI and that we initialize the different SFF to know where they sit on the service index. All of this is included.
Yes. Yes.
Yeah.
And that goes across multiple machines, right?
Yes. That's correct. Yes.
Yeah.
Well, that's, I'm not sure terminology-wise, maybe. The SFF doesn't necessarily have to be there. The VM is connected to a VRN,
Uh,
an
Oh,
OVS
it
switch.
has to be there because it has work to do on the NSA.
Yeah, but it doesn't, I mean, it doesn't have to be there initially. It's just that when that port happens to show up on an OVS switch that is the port for a service function, and they know, oh, I need to go down and program my tables. on
Well,
that
I think
switch.
it's just the mechanics of how OBS is constructed. I thought that actually when everything is up and running, you should already have an OBS image over there that has the SFF enabled, and you don't have.
Well, they don't need to program any flows on that switch until they know that there's a.
But if I didn't have the SFF entity running as part of the OBS, how would I fire it up now that you're asking for the service? So I thought it actually is already up there.
How much time do we have?
You need to populate the tables that say for this flow, you are sitting on by such and such, and your service index such and such.
We have 15 more minutes, right?
I agree. You're right. SFF functionality has to be there. For example, NSH forwarding capabilities, no doubt. But from the north, as you said, you need not say that this is an SFF. I mean, you can discover later as well. There are a couple of things probably you can take up later, after this thing as well. How to model it. The thing is, the problem is the northbound, you have to provide one SFF, though technically you may not need because the RFC itself demands it, and even the IETF draft, which defines the YANG, demands that you have a pair of SF, SFF, SF, SFF. Now you can have a kind of a virtual SFF or a physical SFF. I mean, those kind of things where we can enhance this so that we discover later. Okay.
So would you get to create the tables, right? Do you have to do anything to the switch before that? Because neutrons, you could have a whole set of compute nodes out there, and you don't know ahead of time which ones are going to host
Right,
the service function.
Right.
That's right.
Until the time that Nova decides, oh, I'm going to put this service function there.
Yes.
And then it tells you, and at that point in time, you need to go and set
Yes.
up the service function forwarder.
That's
When the
correct.
first one- When the first one shows up on that compute node, you go and create, initialize your tables and
That's correct.
such. That's what I was.
Precisely that's right.
It didn't have to be there ahead of time.
Right.
Is what I was.
Yeah.
Yeah, but
My question.
Right.
that's correct. That's precisely what it is. But that entity has to have, say NSH forwarding capability, for example, if it is NSH. I mean, you cannot just bring up a VM anywhere and then expect it to do NSH forwarding. And if that OS doesn't know how to do that, yes,
Well,
it's
there's
a trouble.
other stuff that goes into the Nova scheduling the service functions, like is it DPDK enabled, or
Yes.
is there some hardware acceleration or something that's needed by the service function, right? But that's kind of outside the scope of this.
That's outside, and you actually, like enhance platform awareness is functionality that's already integrated into Nova. So that supposedly is the way that placement is being selected. That is orthogonal to anything we're doing on SFC.
Jeff, go ahead.
So I'm trying to figure out that for when you see VM movement event, so you see same name popping up somewhere else. So you are going to resolve over interface name the OBS ADS, and you will also change SSP.
Yes.
It could be
Yeah,
somewhere else.
yeah.
So
That's
you're
right.
doing backwards resolution going back.
Yes, yes. The controller will have to do that. So there are certain restrictions to it. When we're having some discussions earlier, sometimes okay, Nova might move independent of knowledge of SFC. It will just move things. So it may so happen that you may not want automation because when it moves there, okay, I want to change my SFC configuration because probably it has moved to some node which is pretty busy or whatnot, right? So you should be able to change also if you want. But if you don't want to, you can model your service SFC configuration such that, okay, if a VM moves from, say, one switch to another switch, this switch I'll put them together kind of in an abstract way. If they move, VM moves around across these switches, you reprogram the forwarding plane yourself. I am not going to change the northbound configuration of the service chains. So that is where what you talked about comes into picture.
Who is in charge of doing this? To understand the backward relationship between SFF to SFP.
Yeah, that would be the enhancements that we need to do in the SFC.
Future work.
Yeah, that's the thing we are proposing, in fact. Yeah.
Like you guys talk about load balancing.
Yeah, yeah,
Go to the next.
yeah. Yeah, so here I'm just basically going over some new use cases here, and in addition to the improved configurability that we spoke about, right, with the SFF, that you don't need to configure that anymore. So now integrating with this IF interface manager from the Genius project, as I mentioned, improved configurability, but then it will also allow us to more easily implement failover recovery and load balancing. That's what I wanted to go over in this slide here, and then go ahead. Yeah, here's, take that.
Yeah, so, okay, I mean, I don't have to worry, too much about the tables, but in essence, what it means is this. Currently, the SFC data model has a limitation that you can do load balancing or failover across SFFs that are connected to the same SFs that are connected to the same SFF. Let us say VM1 and VM2 are connected to OES1, okay? Now, you can do load balancing of service chain path packets across VM1 and VM2, or you can do failover. But you cannot do load balancing across VMs connected to, say, OES1 and OES2. The data model itself does not allow that. In a cloud environment, this is a very serious limitation because OES1 and VM1 and VM2 may be housed in the same compute host. And if that goes down or gets disconnected, then real failover is not actually realized, okay? Same thing holds with load balancing also to some extent because after all, both of those VMs, they are executing in the same compute host. Okay, you may partition with virtual cores, but then they still at the end of the day consume same hardware resources. So you're not really getting the best of bugs, for load balancing. So what we intend to do is we can do it across. I mean, if you look at this here, going back in the SFC configuration, now you group VMs together as in the ODL implementation. Group VMs together, that is not VMs really, service functions together, call it a like load balancing group or a fast failover group, attach it to certain SFF. What we are proposing is instead you can have these SFs, these two red SFs here across the two SFFs or the two switches. I shouldn't call it two SFFs, it's a modeling, you can however you want to model. So the packet comes in here. So what you can do is you can, let's not worry about table zeros and this thing. So essentially what we are planning to do here is the packet can be load balanced across the two SFs here. We can group them together, okay? So load balancing naturally acts as kind of failover as well. Let us say this VM dies, or this SF dies, and all the traffic shifts here. So that is what we are trying to do here. The weight here is 50% each, okay? So
there are two ways to do that. Is that going to be on the same SPI or on a different SPI? Which really means, do you do the decision locally or do you do the decision globally?
It would be, the decision would be here in the previous hop of SFP.
Would you also do
across classifiers.
Visual classifier,
Mm,
be able to select among load balancing.
yes. That's how it would look like. I mean, let me talk
You
about.
could do it at any point in the
Yes.
in the path.
Yes.
You have to use different spies, right? Because otherwise you would have two
Yeah, I think so.
SFFs that are programmed the same way, and if the packet for some reason gets to the other one, so you really need to have this as two distinct spies, I believe.
The thing is at this point, say this table with SFC logic, say it is forwarding based on service path ID and SPY, okay, service path ID. So out here, that instead of directly pointing to a particular SF, it will point to a group instead, okay, and that group splits the traffic across these two SFs.
But each group entry
Mhm.
would have a different service path.
No, that's what we want to avoid. I mean, let us say that like it can lead to.
Service path ID. You don't think it would be you think it would be the same service path ID?
Yes.
But a different
Uh,
service function forwarder?
Yes, that's correct. So we want to use the same service path ID. Okay, that's how they would be programmed. I mean, in here, so you do the group logic here, and then over an encapsulation, say VXLAN, you send it here. Okay, here we would have programmed. Okay, don't try to do any more load balancing, just send it across.
Why would, so you might even want to go load balance to say, if you use different service path
Mhm.
indices,
Yes.
you could, it seems that it's more flexible because you could even go to the same service function forwarder, but to do different service functions, or to do different service
Yes.
function forwarders, do different service functions. And you wouldn't
Yeah.
have to really worry about the,
It
simplify
it does. We don't preclude that, but we are adding it on the top of it. The advantage here is this. I mean, let us say instead of 1, there are 10 here, right? So all of them, then, the way, if you want to do load balancing across them, one way is like, okay, define a separate path, okay, SFP, and do load balancing across them, start right from the classifier, let us say, okay? The second one is, I don't want to configure so many service paths, okay? To me, all these are firewall entities. I want to group them together, just have one path, okay? And just spraying should be done.
How do you debug this? You wouldn't even know where which path was taken, because if you have a path defined, then you can say this packet took this path. In this case, if you have 10, you have no idea what happened.
Yeah, that is dependent on the hash here, the OpenFlow forwarding, the hash here. But even if you have two separate paths, at the classifier, again, we'll have to do some kind of hashing to send it on path 1 or path 2.
But
Right?
you would still be know what the path is. You cannot report the path in this case. Is going to be very difficult if you are doing it at a very.
Yeah, I mean,
Once the started traveling, do it at the start. You know exactly what the path.
yeah, so then the thing is, if you want to do it across paths and if you want to have control, disadvantage there is you have to manually, let us say that, okay, here is a classifier, not GBPs for simplification, ACL. Then you will have to say that if it matches this ACL, like there are say million ACLs, this ACL has to take path 1, this ACL has to take path 2. You have to manually divide it across paths if you want to.
Not really.
No, there is another problem with this approach. One, I fully agree with the visibility, debuggability, but there is another issue. Somebody is going to go and assign the different weights, and the question is, who's collecting the information that tells you what is the current flow? And that is, so if you imagine that somebody is collecting information from the whole infrastructure and is trying to balance the whole situation, I don't know if putting that at this level inside an SFC project is the right solution. It would be easier to do it right now because it's short term and we could show that we have load balancing, but the reality is going to be that I want to take a look at my infrastructure and based on whatever flows, whatever load of my platforms, I may want to allocate this. So putting something static here at this level without closing the loop where you collect the.
Yeah. You're assuming this is going to be dynamic load balancing, and I'm not thinking that's the case.
How do you keep account of the load?
Sorry?
How do you keep account of the load?
That's exactly
That's what
the
you're
point.
saying. How do you know what the load is?
Yeah.
The load is, the telemetric that gives you that information is not going to close the loop at this level. That's exactly the issue.
No, essentially you have to monitor this, of course. The monitoring that talks about load, I mean SFC data model itself talks about it. So, I mean, that monitoring is independent, but to close in the loop, yes, I mean, it has to configure and come back, and this is the group, right, has the split here. This has to be changed. Okay. Then again, it's again in here is it's a hash ECMP based load balancing. So yeah, so that's why I mean you assume that I mean if you say it is 0.7 and 0.3,
A
right?
different way to ask the same question is to say, okay, so we started with 2. At some point, we may go to 3.
Yes.
Or to 5 or whatever. So you have to assume that somebody is collecting that, and I don't think it's at this level. And whoever collects that is at the orchestration because they need to instantiate another VM when I want to go from 2 to 3 that are being load balanced. So I am going to have that mechanism at that level anyhow. And this is why I'm saying, if short term we simply want to show the capability, fine, but I don't believe that that is the final home for that kind of capability.
So Uri, I think what I understand is Vinayak will provide the interfaces to configure the weights and let an external monitoring application do the weight configuration.
Yes.
But
Yes.
you're still creating duplication because the functionality here is only going to be partial. So you need something at the orchestration level
Yes.
to collect the load, to decide I want to spin another one, no, I want to kill one because I don't need it anymore. So all I'm saying is that when we evolve to call it the final phase of this evolution, it's not going to look like this. So the only reason to justify this for me is to say, sure, there we want to show something here, but it's not exactly the way.
Yeah.
Or the SFC will just be providing a mechanism for that external monitoring guys to configure.
That's what it is. In fact, this doesn't really talk about the orchestrator closing in the loop. Yeah. So, but yeah, you need both. Yeah.
Where we kind of proposing the idea is you are actually solving that problem by placing the VM where load is highly spun. Right?
Yes.
So basic load balancing we are that's something should come from.
That's correct.
Now internally, I think the grouping and the weight deploy because there is a link level load balancing. If you want to do load, you want to do this,
Right.
So that's where I think this is also kind of required at the low level of it. But you don't really have much control of it.
No.
There are monitoring and
That is true. So essentially, I mean, whether you do it across paths or whether you do across within a hop, either way, SFC itself cannot decide on various things. Yes, and that's not what we are saying here either. We are just talking about a data plane load balancing. Yes, someone has to feed this, the number of buckets, everything. I mean, that has to come from north. It's orchestrator that spawns or kills VMs. Yes.
Just to restate that,
I have a
Yes.
very fundamental question. I mean,
Sure.
the arbitration taking dynamically elastic, making the cloud elastic.
Yes.
So reducing the I understand that. From a purely from a single SFC perspective, if you say let's say firewall, the typical deployment will there be a HA proxy in front of that, in front of the forms and the forms, or is that or that's not the case? That's why we are doing this.
Yeah, I mean, that is one way of doing it. So the HA proxy is, an OpenStack way of perhaps saying, okay, this is a kind of do load balancing. That's right. But then SFC itself, I mean, our solution, it's not dependent on OpenStack as such. I mean, it's on the data plane itself. You need to provide some kind of load balancing, right? That's what we are talking about here. Maybe HA proxy can translate to this when it comes down all the way.
Be one of the service functions.
Yes. Yeah.
Because it's a dedicated load balancing.
I mean, HA proxy could be one of these functions. It can translate to this. And then all you say is, okay, send the packets there, and that will take care of load balancing. But this is like, if you want to do load balancing, the switch itself. All right? That's where the SFC load balancing groups come into picture. I mean, you do load balancing in packet spraying in an SFF, basically.
So it seems that you're mainly, just to restate what we were talking about earlier, mainly providing the mechanisms
Yes.
for for doing load balancing, and something's got to configure it.
Yes.
Probably to start, you'll just have a way to do it statically.
Yes.
You could add more
Yeah.
intelligence later. I do think that you should, it should have the ability to do load balancing at every point in that service path, from the ingress classifier, to each
Right.
service function. And you might want to split traffic. Maybe there's a service function that requires a lot of cycles, so you want to split it, but then you might want to bring it back.
Yes. That's right. I mean, it has to be all along the service plane. Yes.
But in this environment, right, where the OBSs are running kind of on a host system, right? If you look at the topologies, it's although we are looking at this topology in that way, but it's going to be very linear topology. That you have a tab port that is connected to the compute host, right? So there is no intermediary node as such. The intermediary node itself is kind of a host, right? So the rest of the switches don't come into picture. So it's always going to be on a host, where the end host, where you put all those rules, right? And then decide which port to go, right? This is one-to-one kind of, mapping here. Connection is between two hosts, direct hosts. Intermediate switches or the network part is that never comes to a part when the solution is kind of host-based thing.
I'm not sure I follow.
Yeah. So all these flows, right, that need to be at the host level, right? So you kind of that where your destination, SF is, right?
Take a picture of everybody.
All these things are installed at a host.
Okay, we're done.
That makes a direct one-to-one link.
They're installed at the initial classifier, and also at each service function forwarder. Right, which could be on different, they could be on the same host, they could be on different hosts.
As long as you have a direct connection between the SSF and the service function.
Right. I mean,
Yeah. Well, is that necessary?
Could be on the same host, but it could be because it's a VPN between a physical switch, or it's a cable between the SF at the bottom and the SSF at another bottom.
right. I mean,
It's a direct connection.
that's right. I mean, okay. All we are saying here is earlier you could do this ECMP based one within the VMs that are connected to the SFs connected to the same switch. Now we can do it in across. That's all. I mean, we are not introducing that kind of non-determinism because of ECMP. It already exists in SFC. It's doing the hash between SFs connected to the same SFF actually. It's there already implemented. We are just spreading it across SFFs. Yeah.
So if you're doing the hash and there are two nodes which are very active, so all the nodes will go into the same hash. And if you split it, how do you make sure that the services which need state go to the same?
Thing is, if you do ECMP, the 5-tuple hashing, all right, same flow will end up in the same.
You know what? ECMP has issues.
yes.
We already know. There are a lot of papers published which says ECMP
Right.
has issues. So
Agreed. I mean, the thing is this. I mean, if ECMP applies to you, I mean, is useful, such a solution where in its typical open flow load balancing, this one, the groups, we are not doing anything new. So what it means is this thing. I mean, there are solutions where ECMP suffices, but the handicap we had was only within the same vSwitch you could do. We are extending it. This one. So ECMP itself is a problem or not? Yes, that's a topic, separate
I was
topic.
wondering if you go between these switches, what if a service needs a state and the state was on one of the VMs, and then is it possible, or you will avoid it somehow that it does not go to the other VM?
Yeah, this is about general load balancing. So let us say that here is, see, the state got built, okay? We kept moving certain packets because of 5-tuple hash, assume the same flow, it always ends up here, okay? Now let us say this dies, okay? Then all the packets will start moving here.
I'm saying not died, it's overloaded, for example, whatever.
Yeah, that's right. So you change the load, and then let us say that this changes, this distribution. Then some flows must start going here. So in general, in such load balancing, they have to sync the states across. So that's the general limitation of any of this hash-based load balancing. So that's not what we are trying to solve here. We just
So maybe you may want to keep it sticky, that if the flow is already going to one of the VMs, you just keep it there.
Yeah.
And if only for
There
that
is
flows, you
fundamentally, there are many research papers about this. So maybe I won't immediately move the flows here. Some of the them we can keep them here, okay? Then, only new flows are moved here, yes. But however, the problem is this. It is not under the control of SFC because the open flow load balancing doesn't allow you to do all these things. The standard open flow, all it lets you do is, okay, here is the n number of buckets, what is the weights? And now you do the splitting. If, okay?
Open flow is not.
So that is a standard open flow way. I mean, if you can do something smarter using some other southbound, fine, okay?
That actually creates a problem, the use case itself. That if you overflow actually, I'm not sure how it will allow the stickiness, but the point is any of these as require a state exchange or a state
Yes.
linking, then if you do the load balancing at that level, you are basically putting the assets and whole chain in kind of a state where you can't recover. So it need to be optional to the user whether they really want to do the load balancing or not, because the kind of load balancing you are doing that actually will put assets in a different states.
Yes.
They don't really want it until unless you provide the stickiness. That stickiness is there, we are fine. Right?
That's right. So see, that's a thing. I mean, that's a problem in general with these kind of open load balancing. I mean, we are not trying to solve that here. What we are trying to solve here is, okay, in some cases, there is stateless. The handicap, again, I'm going back, they were in the same vSwitch. And if this compute host which dies with the switch and both the service functions, okay, that is what we are trying to, this thing.
We're gonna get kicked out. We're about out of time,
so,
basically. So
what I mean is this open flow based load balancing already exists in SFC. That happens between the VM here, one more VM here. So we are trying to spread. I mean, that solution we can't solve it. Yeah.
Respect, I understand, right?
Yeah.
But the point is you switch it over, but if the switching is of no use because the state is not in a sync and it's not going to be used.
No, but it is the orthogonal program.
Yes.
There is an implicit assumption here. All of those service functions that you're load balancing across are potentially from the same vendor. They are homogeneous and they come with their own way of syncing states. Otherwise, this is not working. That is completely orthogonal to that product.
Yes.
That's the point.
That's right. That's what I'm trying to say. I mean, that problem, that state stickiness, we can't solve. Yes, as you said, in that case, you don't want to do ECMP. You have the option to, exactly send it to the different path.
Oh, what happened?
Yeah, with that assumption, it makes sense.
Yes, I mean, that assumption already exists in SFC. But they happen to be, again, I come back, in the same computers, we are trying to spread it. That's all. I mean, that problem we are not trying to address it here. As I said, it's orthogonal.
Right and now it says I want to allow stickiness or not allow stickiness.
Okay. If you use this method, at least standard open flow doesn't let you say that, okay, sticky or not. Then you go back to the old method where you define different SPIs, different service paths, and map the way you want. So then it will stay sticky. I mean, we are not precluding that. This is like in between, in a hop, I just want to spray, all right? So I don't want to, like if there are hundreds of them, I don't want to specify 100 paths. If I want to do it that way, I can use this method.
They should be available on the website, but I can send these slides to the SFC dev list. Is that, yeah? All right. We are out of time, guys.
Already,
This
yeah.
was a lot of fun. Lots of good comments and questions. Thank you, everybody. Yeah, I guess if you want, we can carry on later, but yeah, thanks.
Yeah, we'll be around. So.